Hi guys, here's the pre-calculus test 1B correction videos. Like I told the pre-AP guys, this is not either test A or test B, so no one's going to have all of these questions. But I wanted to do problems similar to them so that you can go by the model that I do in the videos and come up with the right answer. So I'm not doing the corrections for you, but I'm giving you a similar problem to show you how it's done. So for number one, we're looking at this graph, and I'm sorry that it's so ugly. It got blown up and then blown up again. We're looking at this, and we're trying to figure out where is this guy increasing. So remember, we always read our graphs from left to right like we read a book. So always from left to right. And as we're going from left to right, we are asking ourselves, when is the graph increasing? So as I go left to right, I'm getting bigger on this portion. So that's when x is from negative infinity all the way up to -1. And then I'm also getting bigger from right about here to positive infinity. So from, let's say, 0.3-ish to positive infinity. Keep in mind, your intervals for increasing and decreasing always have to be parentheses, where you're never increasing or decreasing when we're at a point. So always parentheses around your intervals. And so this portion that's in between the middle, so from when x is -1 to say x is 0.3, we are decreasing. Now these points here, these are maximum and minimums. That's when we're going from, this is really weird, from increasing to decreasing or from decreasing to increasing. And so those are not constant. You'd have to have a flat area. It'd have to be flat for a good portion of the time before you'd say it's constant. All right, same thing here. We don't have an absolute max or a minimum. This guy is going up to positive infinity, which means you can't say that, oh, the absolute maximum is infinity. Why not? Because the idea of infinity is it keeps on going on and on forever. So I can't ever say, okay, I'm at infinity, there's my maximum. So not true. So even though it's got a space form, we don't have an absolute maximum, nor do we have an absolute minimum, because down here it's going down to negative infinity. We do have a local maximum, though. That would be this point here, which is at -1, +1. And then this point down here is our local minimum, and that's roughly 0.3, -0.3. You could argue something else, and I'd probably buy it as long as you're in the right area there. All right, number two, the height of a firework T seconds after it is launched is modeled by this function. Find its average speed from 1 to 3 seconds. So average speed is h of the second value minus h of the first value, all over the second x minus the first x. So we need to figure out what is h of 3 and what is h of 1. So -16 times 3 squared plus 15 times 3 plus 5. That's what we're plugging into our calculator. I'm just going to grab a calculator. 3 squared would be 9, so I've got -16 times 9 plus 15 times 3 would be 45 plus 5, I get -94. That's just for plugging into a calculator. Same thing for 1. I've got -16 times 1 squared plus 15 times 1 plus 5. So that's -16 plus 15 would be -1 plus 5 would be 4. All right, so for h of 3, that's -94 minus my h of 1, which is 4, all over 3 minus 1, which is 2. -94 minus 4 is -98 divided by 2, so -49. Don't forget to put your, it's a word problem, so don't forget to put your units on there. So this would be feet per second. All right, number 3, very similar, except for this time it's not a word problem, so you're not going to have feet per second. Remember, you could have done 2 or 3 on the test. So again, this is f of 3 minus f of -1, all over 3 minus a -1. So f of 3 would be negative 3 to the fourth plus 3 times 3. Negative 3 to the fourth is negative 81. 3 times 3 is plus 9. Negative 81 plus 9 would be negative 72. And then f of negative 1 is negative times negative 1 to the fourth plus 3 times negative 1. Negative 1 to the fourth is positive 1 times this negative still would be negative 1. 3 times negative 1 is negative 3, so negative 4. So f of 3 we said was negative 72 minus f of negative 1 is negative 4. So minus becomes positive 4. On the bottom I've got 3 minus a minus 1. Again, these guys become positive, so 3 plus 1 is 4. Negative 72 plus 4 will be negative 68 divided by 4. And that, oops. Negative 68 divided by 4 is negative 17. Again, it doesn't need feet per second because this is not a word problem. Okay, go ahead and throw in number 4 for this one. We've got the greatest integer function. A lot of you got good at plugging in the 5.75 and then kind of lost the idea. So we got 5.75 minus 2.5, or you have some sort of similar number. So 5.75 minus 2.5 would be 8.25. Now, what does the greatest integer of 8.25 mean? That means, what is the biggest integer that is less than 8.25? And that would be 8. So this is negative 3 times 8. You can't multiply negative 3 times this guy and then take it. You got to deal with the parentheses. Think of these guys as big old parentheses, even though it does something else. But you can't multiply inside of them or add or subtract inside of them. You've got to take care of what's inside of it, take care of the greatest integer part, and then do your multiplication. Negative 3, lost my negative. Negative 3 times 8 is negative 24. All right, that's 1 through 4. The next video we'll get 5 onward.